All right, guys, we're in the second part of Compound Inequality Part 1, Part 1b. Now, I love this part. This part's going to be translating inequalities. This is like translating equations or translating expressions. All right, so I know that x, for this one, x has to be bigger than -3, and x has to be smaller than 1. I can literally just leave it like that. We're good. Now, the next part right here is something, there's space in between. It's not overlapping, so I know it's going to be an or statement. So I know for this one, I'm going to have two inequality statements. I know that x is going to be less than -2, and it includes 3. So I'm going to say x is greater than, I'm going to put this or right here. X is greater than 3. Looks like we have another or statement. So I know that x is going to be less than or equal to 0, or x is going to be greater than or equal to 2. That's for this one right here. When we draw these in, oh no, go back. Where are you at? There we go. Let's draw this in like that so we know that's inside. Let's do this final one. Now this one's going to be an and statement because it's overlapping inequality right here. So I know that I could put and in the statement, or I know that I can put it as one big long statement. So it's bigger than -4 or equal to, because it's a closed circle, or and, not and, or, and it's less than 4 or equal to it. All right, these next ones right here, we have 9 is less than a number, is no more than 8, and no less than 3. Okay, well, so we're going to put this 3 right here. We know 3, it's no less than. So we can take this, no less than. So it can equal 3, and it's going to be no more than 8. So that's, we just dealt with this right here. No less than 3, no more than 8. Now, technically, we could have reversed it as long as we make sure the inequality is eating the 8 and the little part is stabbing into the 3 right there. We could put that. So it says 9 less than a number. So 9 less than 10 would be 10 minus 1. So we could put x minus 9. There, that's it. It doesn't ask us to solve it. It just asks us to create it. Okay, so it says the sum of 4 times a number. So the sum of 4 times a number, so I could put fx, and 8 is between 0 and 12. Okay, so I know it's between 0 and 12. Now, it doesn't say it includes it, so I'm not going to, that wouldn't be in between. That would be on 12 or on 0. So it's going to be in between 0 and 12. Doesn't ask us to solve it, so we're good. Next up, it says 1/2 a number increased by 3. All right, well, let's just write this. So we have 1/2, maybe we want to put n, increased by 3. Okay, let's add 3, is greater than 0. All right, well, that's greater than 0. Or, now we're done. We're done with that. That's one of our inequalities. Or less than, or less than or equal to -3. Ooh. So now we have to take it. So they're telling us 1/2 n plus 3 is less than or equal to -3. So it said, hey, look, this guy right here, let me put in green underneath. This guy is greater than 0, or this guy again is less than or equal to -3. Okay, well, there we go. All right, this next one. Now, this one's a little bit longer because it has a lot of words, so let's go through it. Each type of fish thrives in a specific range of temperatures. So what? Don't care. The optimum temperature for sharks range from 18 degrees Celsius to 22 degrees Celsius. Okay, so we understand if it's shark wants to be between these two temperatures. Okay, cool. Is that what it's asking? Write an inequality that represents the temperatures where sharks will not thrive. Oh, not thrive. So what numbers are not 18? And technically it says from 18. So we could put this. It could include 2. But it doesn't say include. So we'll take those off. We'll take them off from now. All right, so the numbers so this would be 2 statements. So normally this is what it would be for shark live. Shark lives. But they don't want this part. They want this part. So it's going to be x is less than 18 or x is greater than 22. So they gave us this. They said this is where sharks live. This is where sharks don't live. They'll sleep forever. All right, here we go. About 20% of the time your sleep is spent in rapid eye movement, REM sleep. Okay, we want to care about that, which is associated with dreaming. If an adult sleeps 7 to 8 hours, how much time is spent in REM sleep? Okay, well, give me a second here. All right, so this one's going to be we're going to have to just kind of tell you with this one, okay? So let's say I have 100% of something, but I want to get to 20%. What divided by, or what times 20 will equal 100? Well, it would be 5 times 20. So then we have to understand if it's 100, if we want to sleep 100 hours, we would divide by 5. And that would give us the 20% we'd be sleeping. How many 20%? Well, let's say we don't know that. Let's just say how much we understand. We could write down this. Let's write this down. We could say let H equal the number of hours of REM hours in sleep. Okay, so if we're going to sleep 100 hours, then be 20 times 5 would give us that 100 hours of total sleeping. Now we understand that 5 is going to be 5 times, let's say, H. 5 times H would equal 8 or 7. Now this is one of those how do you get fractions, how do you get percentages type of deal. But just remember this. Let's say it's between like 100. Let's say this total was 100. We'd want to have 5 times what equals 100? 20%. Well, we know it's 20%. So it's 20% times what equals 100. And that's where we come up with 5. So 5 times H would give us 8. Now this one, it says how much time is spent in REM sleep. So we would actually divide by 5 on both sides. And technically, this is 2 different inequalities. So we're going to divide 5 on the left and 5 on the right. If we divide 5 on the left, we're going to get something around like 1.4. If we divide 5 on the right, we would get something like 1.6. So between 1.4 hours and 1.6 hours is how much REM sleep you get. Now on this, I want to do it like this. I would separate it into two different inequalities and then solve for 7 is less than 5h, and then solve for 5h is less than 8, each one of those, and then bring them back again. Just so that I know that I am using the properties of equality correctly. All right, final one. A store is offering $30 million. Oh, sorry, million. $30 mail-in rebate. I wish it was a $1 million mail-in rebate. Store is offering $30 mail-in rebate on all color printers. Luis is looking at different color printers that range from the price $175 to $260. How much can he expect to spend after the rebate? Okay, well, let's put printer or price of printer. So, I mean, let's put P, let. So we're going to say let P equal price after rebate. Okay. So we can understand there's going to be a compound inequality. We're going to have, we want it between 175 and we want it to be below 260. Okay, well, we understand that it's going to be P plus 30. So we're going to subtract 30 on both sides. Now, once again, I could keep it like that, or I could separate it. I would highly recommend separating it. This gets rid of a few issues that we might have. So now when we subtract by 30 on both sides, we're going to get a more accurate representation. We can bring it back. So when we subtract by 30 on both sides, we get 145. P is going to be between 145 and 230. So there's that. All right, guys. Thank you very much. I look forward to seeing you in class. Bye, everybody.